This is experiment number 3, regression analysis. So first one is linear regression. So for that we'll import all the necessary files and the CSV file required to perform all the operations on. And the first question is perform a data cleaning to find the missing value and impute the same value with mean. So what we are really doing is we'll just find the missing columns and missing rows and then fill it with the mean of the average of a particular column. So here before filling the values, the number of missing values is 2052, and then after filling it's 3. So here I'm using the isNull function dot sum function dot sum to find the missing values, and after that df dot select input is the entry dot columns. It will give the return the number of numeric columns in that particular status set. In order to fill it, I'm using fill and name. I'm using mean of that particular column to fill the missing values. So next question is choose the independent variable x and dependent variable y for the given data set. Since it is linear regression, we'll take only one x variable, that is alcohol, and y variable as quality. We'll just assigning the values to x and y here. Next question is compute the b0 and b1 using the formula and display. So b0 is basically the slope and b1 is the intercept. So these are the formula for finding the b1 and b0. b1 is equal to numerator by denominator, and b0 is equal to mean minus b1 into x mean. Y mean minus b1 into x mean. So next is formulate the equation for y product and calculate y product. So this is a formula b0 plus b1 into x as a formula for y product, and display this. Calculate the sum of squared error. The SSC is a metric which shows the sum of squared error. So this is the formula. That is y minus y product, that is error square. So the next is RMC, that is the root mean square value error. So here we'll just take the square root of SSC by n, where n is the length of y. Is calculate the coefficient of determination R2 square R square. So the first formula for R square, that is y minus y mean square. And again that is the denominator, and that's the real formula for R2 is 1 minus SSC, that is this one, that is sum of squared error by the denominator that we calculated here. So the next one is the graph. This is the regression graph. So the one line that is going there, the red color is the regression line. So this line closely passes through all the data points here. That's what we call the regression line. And the next one is predict the y for a given x value. So this one is for actual prediction, and radius is equal to, but we'll use the formula b0 plus b1 into x value. That is the formula for y product. And here we're taking 1 to plus 11, and then there is the output that I have. We're going to the next is this one is multiple linear regression. So what's the difference between multiple linear regression and single linear regression is for multiple linear regression we will get 2 or more x values, while in the single linear regression we'll just take one x value, that is maybe 100 method. So first we import all the necessary data frames and thing into this, and then import the CSV data frame. Then perform a data cleaning to find the missing values and impute the same value with them. So as we confirmed in the linear regression, there also we'll find the columns with missing values and then fill it with the mean for a particular column. Next one is choose the independent variable x1 and x2. And so here we are taking 2 multiple linear regression. So the dependent variable y from data set is quality. So that's taken here as y as quality, and x1 as alcohol, and x2 as sulfate, and we're currently the same. Next, compute the y-intercept and independent variable coefficients using the formula and display the same. So first we'll find the x matrix. That formula is NP ones of x1 x2 with x1 and x2 as it's more like a 2 by 2 matrix, and then we'll find xtx, that is the x transport of x into trans t of x is t, something like that. This is equal to the formula was there, and then we'll take the inverse of it, and then we'll just multiply x into transpose of y, and finally we'll take NP dot of x transpose of x inverse into x transpose y. So we'll get b0, b1 and b2 for t there. So I'm just putting this in. We'll formulate the equation for y predict and calculate y predict. So here the formula for y predict with 2x1, 2x variables is b0 plus b1 into x1 plus b2 into x2. Now similarly calculate the SSE. SSE is sum of squared error value, and the formula is also same, that is y minus y predict, that is y actual minus y predict, so that is square. And then root mean square value, similarly SSE by n, where n is the length of that particular direction, column. Next is r square, similarly using the same formula, y minus y square as the denominator, and r2 is 1 minus SSE, the error that we found earlier, right? Now predict the y for a given x1 and x2 value. So the prediction is made using the formula b0 plus b1 into alcohol plus b2 into with the two input variables 10.5 as x1 and 0.995 as x2. So going to the next is logistic regression, and similarly import all the necessary into the data frame, and then for the file as well. Then perform the necessary preprocessing. Here we are using mean computation with mean values, a label encoding to convert categorical to numeric value. So we are using a label encoder. No, yes, we are not using scikit-learn. Here we just fill the missing values with means, and then we'll identify the data type, and then for white I'm assigning 0, and for red I'm assigning 1. So it's encoded without any scikit-learn function. And next is choose a variable x1, x2 and dependent variable y for the given data set. So taking x as the values that is already given in the question, that is fixed acidity, volatile acidity, critic acid, residual, sugar, etc., etc. And then for y I'm taking the type encoded values of white and red. And after finding that, the shape of x and y is also calculated. So the next question is calculate the cost of error and reduce the cost of error using gradient descent. Here we are using a sigmoid function whose formula is 1 by 1 plus the minus exponents of minus exponential value of minus z. This is a constant. Then the necessary cost is calculated using the formula, and here we are taking the lambda rate as 0.01 and number of iterations as 1000. So we'll calculate the final cost as 0.1247 and the final weights as shown here. Now this is the graph for iteration against cost. So it clearly shows that as iterations increases, the cost is decreasing gradually. For the next question, let's find the model accuracy. So the accuracy that I got here is 98.58%. Thank you.